Okay, the last topic we're going to do in operations and rational expressions is adding and subtracting. So we want to think about how do we add and subtract regular fractions. Well, we know we have to have a common denominator. So if the denominators are the same, all you do is combine like terms in the numerator. So whether it's adding or subtracting, you combine them if they can be combined. Denominator stays the same though. So it has to be the same and it stays the same. And then reducing if you need to reduce. Okay, so some of the very simple ones already have like denominators. So same denominator, which means we combine like terms in the numerator. So here, 3x plus 7, we can't actually add those together because those are not like terms. So it just stays 3x plus 7 here. And denominator stays the same, 5x squared. Be careful if it's a minus sign. If it's a minus sign, you need to make sure you subtract both terms. We're going to look at some of those today, but just be aware of that for these simple ones. Okay. Example number 10, we're actually going to change, but before we do a harder example, let's come down here and do a couple easy ones, or simpler ones. Not as easy as that, but not too much more complex. So looking at 11, I have 3y over 2x plus 2z over 5x. So notice the denominators are not the same here. I have a 2x and a 5x. So I want to make them be the least common multiple between the two. So they both have an x, so I know that's the least common multiple. And then a 2 and a 5. What's the least common multiple between 2 and 5? It's 10. So least common multiple means if I keep multiplying these, 2, 4, 6, 8, 10, 12, and then this one, 5, 10, 15, 20. Which one is the first one that we're going to come across that's the same? So here, 10 and 10 is the first one, so that's the least common one. So that's what I'm looking for these fractions. So here, I want to know what do I have to multiply this one by to make it a 10x? Well, I have to multiply it by 5, but whatever I do to the bottom, I have to do to the top as well. So here, numerator becomes 15y, denominator is 10x. Plus, over here, what do I have to multiply this denominator by to make it 10x? I have to multiply it by 2, but whatever I do to the bottom, I have to do to the top. So 2z times 2 is 4z, and this numerator, denominator is 10x. So since the denominators are the same, I can add numerators together. So here, 15y plus 4z, those aren't like terms, so those are going to stay 15y plus 4z. And then here, denominator just stays 10x. So you don't add denominators together, you just combine like terms in the numerator. So here, we leave the answer as is. To reduce these, most of the time we're not going to be able to, but to reduce them all by a number, everything has to be divisible by the same number. So we can't reduce it here, because these two are divisible by 5, but this one's not. We can't reduce by 2, because 15 is not divisible by 2. So occasionally we'll have to reduce, but not very often. Okay, so let's do one that requires us to factor. So looking at example number 12 here, and then we'll go back and edit number 10 at the top. So here, the denominators aren't the same, but they're quadratics. So anytime it's a quadratic, we ask ourselves, how are we going to factor this? So we have our unusual choices, GCF, difference of squares, basic, and AC. And here, there's not a GCF, so we're not going to do that one. It's not a difference of squares because it's trinomials. It's trinomials with no number in front, so we know we're going to use basic. So for the first denominator, we ask ourselves, what are the factors of 3 that add to -4? Well, 3 only has one set of factors, 1 and 3. In order for us to get a positive here, they both have to be the same. In this case, I want to be -4. I need them both to be minus. So minus, minus. You can do the x over here if you want, but I'm not going to do those anymore. Okay, so now this is our new denominator. So I'm going to erase this one. This is the denominator now. Looking at the second one, we have -6. We want factors of -6 that are going to add to 5. This one you have to be careful with. To get -6, one has to be positive and one has to be negative. So I don't want 2 and 3, because 2 and 3, I would have to add them. They would both have to be positives, but I want to be add them together and get a negatives. So I don't want 2 and 3. I want 6 and 1, with 6 being the bigger one to be positive. 1 goes here. Okay, so this is our new denominator for that one. So now, these are not the same. They're not common denominators. We want to make them the same by seeing which one it's missing. So here, x minus 1, this one has an x minus 1, so it's not missing that. This one has an x minus 3, but this one doesn't. So over here to this one, I need to multiply this by x minus 3 on the bottom, because this one has an x minus 3. But whatever I do to the denominator, I have to multiply the numerator by as well. So they both get an x minus 3. So now we got to ask ourselves, what does this one need that the other one has? It has a minus 3, it has a minus 1, it needs the x plus 6. But again, whatever I do to the bottom, I have to multiply by the top. So this is actually the common denominator between the two. X plus 6, so I'm going to rewrite it here, x plus 6, x minus 1, and x minus 3. So that's the common denominator for this one. So now in the numerator, let me go ahead and distribute this out. So 4 times x here is 4x. 4 times 6 is 24. So I get a plus 24 here. So now second fraction plus this denominator is all this stuff again. X plus 6, x minus 1, and x minus 3. So now when I distribute this numerator, x times x is x squared, and x times -3 is -3x. So since the denominators are the same, I can combine like terms in the numerator. I know this is what my denominator is going to stay. Oops, one of these is a plus. Plus 6 minus 1 minus 3 over, so I don't have to multiply these out. I'm not going to ask you to do that. Just leave them in factor form, and in the numerator we're going to combine the like terms. So here, the x squared can't combine with anything, so that just stays x squared. The x's we can combine together. So here we have 4x and 3x, -3x. So 4x and -3x is 1x. And then we have plus 24. Now what you should check is to see if you can factor this and if it can reduce. If it can, then you should do that. If it can't, then you just leave it alone. So here if we look at 24, what are the factors of 24? 1 and 24 2 and 12, 3 and 8, 12, and then 4 and 6. So because it's a positive x and a positive 24, they're both positives. So which one of these is going to add to 1? None of them. None of these gives me 1. So this actually cannot be factored further and reduced. So this one is your final answer. If it was factorable, if it did factor out, we would see if anything cancels. If it cancels, we would cancel it out. But none of these cancel, so we just leave it alone. Alright, so we're going to come back up here and I'm going to change number 10. And we'll work that one out as well. Okay, so for number 10, I'm actually going to change the problem from the one that's there. So for A, I'm going to do this fraction right here, 7 over 2 minus 4/5. And similarly, I want to show you how it works with polynomials here. So we're going to subtract these two. So for the 2 and the 5, since they have no multiples in common, you basically just multiply by the other one. So here, to make them the same, you multiply this one by 5. Whatever you do to the bottom, you do to the top. So 35 over 10. And then this one you multiply by 2 to get 8 over 10. That will always work. Multiplying by the opposite denominator might not be the least one, but it's a common one. So here we just subtract numerators. 35 minus 8 is 27, and then divide it by 10. And reduce if possible. Not possible here though. So let's see how it works for polynomials. So here, this is like its own factor, and this is like its own factor. So they really have no factors in common. So here, you're going to take this denominator and multiply it by this side. But whatever you do to the bottom, you have to do to the top. So here we're going to get 7x plus 35 over, again, you don't have to multiply this denominator out, you can just leave it, x plus 5, x plus 2, minus, over here, this denominator needs the x plus 2. So here, x plus 2 on the bottom, or whatever you do to the bottom, you have to do to the top. So the denominator for this one is going to be x plus 5, x plus 2 again. Now the numerator, you have to be careful. So you can distribute the 4, and you just have to remember to subtract. My recommendation is anytime it's subtraction, you make this negative and you change it to addition. That way you don't forget to distribute the negative. So here, negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. And we're going to end up adding these. If you don't distribute the negative, that's fine. Just remember, when you do this, you have to subtract both of them, the x's and the constants. Okay, so the common denominator between them is x plus 5, x plus 2, over, combine your like terms, 7x minus 4x is 3x, 35 minus 8 is 27. So again, here, what you should really check is to see if you can factor further. So if I look at the numerator, both of these are divisible by 3. So I can write this as 3 times x plus 9 over the factored form x plus 5, x plus 2. But notice that these are going to cancel out. If this was the same, we would cancel it. We would reduce it. But very, very rarely are these going to reduce further. So you're welcome to leave it either way, this way. Since nothing cancels, you're welcome to leave it like that. Or you can go ahead and factor and leave it this way. It doesn't matter. But if it can reduce, make sure you do reduce it. Okay, so let's just do more that require you to factor to get the least common denominator. Dot one. So we're here on number 13. So looking at both denominators, they're not the same. So we have to factor this one. So for the first one, it's not quadratic, so we can't do difference of squares, basic, or AC, but it does have a GCF. So here the GCF is going to be 3. So factor out the 3. So this 3x divided by 3 is x. 9 divided by 3 is a negative 3. So this is my new denominator here. Here, it's a minus sign. Perfect square. So this one's a difference of squares. Difference of squares factors into plus minus. And then you just take the square root. Square root of x is x and x. Or sorry, square root of x squared, x and x. Square root of 9, 3 and 3. Okay, so now, again, this is this denominator. We gotta see what's missing. So on this one, what does this one have that this one doesn't? Well, it has the minus 3 factor. It doesn't have the plus 3. So we need to multiply this one by x plus 3. Whatever we do at the bottom, we multiply by the top. X plus 3. Now what does this one have that this one doesn't? It has that multiple of 3 in the front. So here I need to multiply this one by 3, which means I need to multiply this thing by 3. Put 3 over here. It doesn't matter where you put it. Okay, so let's see what we have. Numerator is going to give us 7x plus 21. Denominator is all this stuff. And usually we write the multiple in the front. So 3 times x plus 3, x minus 3. So here I'm actually going to, I'll put a 3 in the front here. So that we change the positive to a minus sign. So I'm going to add negative 3 when I distribute it. So here, distribute the negative 3, and you get negative 3x and a minus 12. If you don't remember to distribute the negative, that's okay here. Just remember to subtract when you combine your like terms. Right, so since the denominators are the same, 3x plus 3, x minus 3, over, you just combine them again, 7x minus 3x is 4x, 21 minus 12, what's that going to give us? 21 minus 12. It's going to give us 9. Positive 9. So here, you ask yourself, can this be factored? It can't this time because these aren't divisible by 4. So this time you don't even have to worry about it. This is your final answer. Now sometimes it would ask you the excluded values. It's like before. What are the numbers that make the denominator 0? It would be negative 3 for this one and positive 3 for that one. Alright, last two examples, pretty much the same thing. Just factor and make the denominators the same by multiplying by the missing factor. Alright, so if we look at the first one, here we have a trinomial with a value of 1. We can use basic. So what are the factors of -6 that add to -1? 2 and 3, with the bigger one being the negative. This one's positive. Right, so this one's gone. This is my new denominator. Right here at the beginning, I'm going to go ahead and change this from a minus sign to a plus negative. That way I don't forget to do it later. Alright, so if we look at the second one, it's not a quadratic, so no difference of squares, no basic, no AC, but it does have a GCF of 5. So I can take 5 out of both, and I'm left with x plus 2. Alright, so let's see what's missing. So this one has a plus 2, that this one has, but it needs the minus 3. So here we're going to multiply by x minus 3, and x minus 3 on the top. So this one's gone here. This is the new denominator. Alright, so what does this one need that this one has? Has the minus 3 now, has the plus 2, but it needs the 5. So multiply by 5. So if we distribute the first one, we get 5x minus 5 over all this stuff is the denominator. 5x plus 2, x minus 3. And I'm going to go ahead and do plus because I changed it to a negative up there. And distribute. Negative 4x plus 12. And we have again this denominator, 5x plus 2, x minus 3. So the common denominator between the two is 5x plus 2, x minus 3. But what I got to do is combine like terms in the numerator. So here, 5x minus 4x is just x. And negative 5 plus 12 is positive 7. So again, this is like its own little factor. So here, nothing's going to cancel. So this is your simplified form. Can't reduce it any further. And if it asks the excluded values, which I think the Khan Academy does, you just say x cannot be negative 2 and 3. But it's not going to ask you for adding, subtracting very often, because you already did for simplifying, multiplying, and dividing. Okay, last example. So here we have 3. We're adding and subtracting each of these. So for the first fraction, they're linear, no quadratics, and really not a GCF there. So this one stays. I'm going to put parentheses around it. Parentheses around that one. This one's linear again. So don't do anything there. This one though, if you look at the denominator, it's quadratic, so we want to factor this one. So what are the factors of negative 10 that add to 3? Positive and negative. So 10 is 2 and 5, with the 5 being the positive one. The bigger one has to be positive for it to be a positive 3. Okay, so this one's gone. So in order for me to add these, I need to make all the denominators the same. So here, this one already has both of the factors that these have. So this one's good. This one I don't have to do anything. I'm just going to leave it as x, 4x squared minus 3x minus 1 over x plus 5, x minus 2. and it's minus. I'll deal with that minus in just a second. Okay, so here for this one, what does this one need that these have? This one needs an x minus 2. So this one is going to end up having x plus 2, or x minus 2, x plus 5 on the bottom, like the other one, like this one does. However, for the numerator, we actually have to multiply this out. So I'm going to come over here, x minus 2, 3x plus 5. We're going to have to FOIL this out. So here I get a 3x squared plus 5x minus 6x minus 10. So when I combine my like terms, 3x squared minus x minus 10. So that's what's going to end up going in the numerator for the first fraction. 3x squared minus x minus 10. And we're actually going to have to do the same thing for the second one. So for the second one here, we need to multiply this one by the x plus 5. So times x plus 5. Whatever we do the bottom, we have to do the top. So we're going to add x minus 2x plus 5 on the bottom. But in the numerator, we have to FOIL this part out. So here, x plus 1 times x plus 5. X and x is x squared. X and 5 is 5x. 1 and x is 6x, or sorry, 1x. And 1 and 5 is 5. So when I combine my like terms here, x squared plus 6x plus 5. That's the numerator for this one. X squared plus 6x plus 5. Okay, so now I can combine them all. Since they all have the same denominator, x minus 2 and x plus 5 is my common factors. I just need to combine all the parts. So I'm going to go ahead and change this one. Since we're subtracting, I'm going to add and then make all of these opposites. So this is going to be negative, positive, and positive. So these are the ones we forget. When we don't distribute the negative, when we don't change the sign, these are the ones that always get left out. So make sure when you distribute a negative, you distribute it to everything. Okay, so looking at the x squareds. 3x squared plus x squared makes 4x squared, but then I'm subtracting 4x squared. So these actually cancel. So I'm not going to have a quadratic term. Looking at the x's, we have negative x plus 6. Negative x plus 6 is 5x. Plus 3 makes 5x plus 3 is 8x. And then we do the constants. Negative 10 plus 5 is going to be negative 5 plus the 1 makes negative 4. So again, you can try to reduce it. This one actually can be factored, has a GCF of 4. So if I divide a 4 out, I'm left with 2x minus 1. But that's not going to cancel with these numbers down here. So we actually don't have to do it this way. You're welcome to leave it like this. But I mean, if you've done the work, you can just write it this way. But you only have to write it in factored form if it has a common factor that cancels out. So if it happens to be the same thing, you reduce it by canceling those two factors out. Okay, so that's adding and subtracting. Again, the biggest thing is finding a common denominator between all of them. Usually they'll have one in common already. You just have to multiply by the other one.